We are asked to find the domain and range of the function f of x is equal to log base 2 of x plus 4 plus 3. The easiest way to find the domain and range of a function is to think about what its graph will look like. In this case, I've started off with the basic graph g of x equal log base 2 of x. This is a graph that has no translations. The base is 2, but as long as the base is bigger than 1, it really doesn't affect the picture very much in its shape. Notice that the log graph does have a vertical asymptote of x equals 0, which is the same thing as our y-axis. The graph will come infinitely close to the y-axis, but it doesn't touch. Now, to find the domain and range of our function, I need to take this function and translate it. In this case, the plus 4 inside the logarithm means that we're going to take our graph and shift it to the left 4 places, which means our vertical asymptote, which started at x equals 0, will also be shifted 4 places to the left, and my new graph is going to have a vertical asymptote, 2, 3, 4, at x equal negative 4. Our graph is also shifted up 3 units, so if you just shift left, our graph would look like about like this. But if we also shift it up 3 units, we're going to end up with a graph that looks pretty much like this. Now, the exact details aren't very important. The y-intercept on this graph would be 0, 5. If I plug in a 0 for x and you do this calculation, you will find that you do get 5. But really, again, what we're really worried about is the shape and that asymptote. Now, remember, the domain of a function, when you're looking at a graph, is found by taking the x-coordinate of the leftmost point to the x-coordinate of the rightmost point, and the range is the y-coordinate of the lowest point to the y-coordinate of the highest point. So, looking at our graph, let's find our domain and range. Now, how far left does the graph go? What is our leftmost point? Well, the graph doesn't actually have a leftmost point, but it does stop going to the left. It stops just before we get to x equal negative 4. So we're going to say that our domain starts with negative 4 but does not include negative 4. So in interval notation, that means we're going to use parentheses for our domain and our start. This graph goes to the right forever, for infinity. So our domain will be negative 4 to infinity with a parenthesis on the negative 4. Now our range is the y-coordinate of the lowest to the y-coordinate of the highest. Well, obviously you can see this graph goes down towards negative infinity, so our range does go down to negative infinity. And there is a little bit of a deception here with the range and your y's. Log graphs grow very, very slowly. Once they hit a certain point, they go up very slowly, and it looks like they might level off and have a horizontal asymptote like they have a vertical asymptote. But that is never, ever the case. Log functions go up forever. They continue to rise and rise. So our range does actually go to positive infinity. And as a matter of fact, the range of every logarithmic function will always be negative infinity to positive infinity. This never changes. The only thing that ever changes is the domain. Now we can shortcut this process a little bit and say that if we have a logarithmic function in standard form, where a would be stretching or shrinking the function, and honestly, in terms of domain and range, this is not going to have any effect, and our base can be any number. It also does not really matter. The domain of this function will always be h to positive infinity, again using a parenthesis on the h because the h is never actually included. And our range will always be negative infinity to positive infinity no matter what. So using these techniques, we were able to find the domain and range of our logarithmic function.